Anyone using Unreal today will notice that state trees are cropping up all over the place, whether it is in AI, smart objects, mass AI, or even the new gameplay camera system. If you want to fully use these fancy new systems, then a basic understanding of state trees is essential. Unreal describes a state tree as being a general-purpose hierarchical state machine that manages state-based logic by organizing it in a tree-like structure, starting at the root and branching down into their states and substates. Each state contains a task or tasks that execute the logic of that state. The tree can then transition from any state to any other state based on transition rules. And the tree, once it has been started, will continue to run until it is ended. Here is an example of a simple state tree with clearly defined states and substates. And even with a single glance, you can intuitively understand what the states do and how they are likely to transition from one to another, especially compared to behavior trees. However, the simplicity does not come at the cost of power, for these are incredibly powerful. Every state can have parameters, conditions, utility AIs, tasks that perform different logic, and different sets of transition rules. And the trees themselves can have different schemas and contexts and parameters and even color themes. There is a lot to learn about state trees, but as usual, let's begin with the setup. State trees are production ready, but they are not fully activated by default. So in order to use the state trees, you do have to go to your plugins first of all and activate the correct plugins. So when you open your plugins, if you type in state tree, the two plugins you want to activate are state tree for general purpose state machines and gameplay state tree, so you can use it for AI or gameplay behaviors. Once you've done that, you can restart your editor. You can then go to your content browser or to any folder that you like, right-click, go to Artificial Intelligence and click on State Tree. Once you do that, you will be then asked to pick a schema for your state tree. And the two common schemas are state tree component and state tree AI component. The way that state trees work is that you add a component either to an actor or to an AI controller, and that component contains the state tree that you want to run. So if you wanted to add a state tree to a simple actor for a non-AI purpose, like opening or closing a door, you would go for the state tree component. If you wanted to create a complex AI behavior, like the example we saw, you would add a state tree AI component to a AI controller. So that would then determine which schema you would go for. If you go to all classes, you notice there is also a camera director state tree schema available by default in 5.5.4. And this relates to the gameplay camera system. But the two that we are interested in are the state tree component and state tree AI component. So if you click on state tree component first, I'll call this state tree actor. And then we'll go back and we'll create a schema with a state tree AI component, just so we can see some of the differences. State tree AI. So now you've created two state tree assets, but in order to use them, you need to create a component which will store the state tree asset and run it. So the first thing we'll do is we'll add a state tree to an actor. So if I right click, go to Blueprint, just create an actor, I call this BP state tree actor, and then open it. As I said, a state tree asset must exist within a state tree component. So the first thing we should do in the actor, we go to Components, we can click on Add, and we can type in state tree. And from here we can choose one of two components. So either the state tree component or the state tree AI component. We want to choose the component which corresponds to the schema that we set for the state tree asset we created. And for this one, it would be the state tree component. So we can type on that and just call that state tree component. When we click on the state tree component and go across to the details panel, we can now choose the state tree asset that will exist in this component. And we will only get options to choose state tree assets that have the correct schema. So when we click on that, we can choose the state tree actor because we chose the state tree component schema for this, but the state tree AI that we created would not show up. Once we choose that, we can then also choose whether the logic starts automatically or not. So in other words, does it start running on begin play? So you can set that to be true here, but if you wanted to start the logic manually at some later point, you could unclick that, and then actually in the blueprint in the code, you can drag off the state tree component, and if you then just type in logic, you should have access to all of these functions that can be called. So start logic, restart logic, stop logic, and they should all work. If you wanted to run multiple state trees on the same actor, you can do that because these are just components. So you could add, and you could add another state tree component. And if you had a different state tree that controls some other logic, you could add that here. By the same token as these are components, you can drag them out and call destroy component. So this would destroy the component and therefore end the state tree. There is also another node that means that you can add a component. So you can type in add state tree component, and you could add a state tree component like this. So if you wanted to add a state tree component to an actor, but it wasn't here to begin with, this node will allow you to do that. And again, on the actual node itself, you can pick your state tree asset. And if you had parameters, you could set them here, and you can decide whether it starts its logic automatically or not. This sometimes might not start straight away, so you may need to then call the start logic node on it. So again, that is how you can either add state tree components with state tree assets using the add button or via code using the nodes, and you can also destroy them. We can do the exact same thing to use our state tree AI. So in this case, we'd create a AI controller, go to all classes, type in AI controller and choose one of the AI controllers. This could be AI controller state tree. When you open that, from the add components, we can choose a state tree AI component. And then in the details panel, we can choose the state tree AI. So this is the one that we created, and this was the example that I created. And as you can see, the state tree actor doesn't show up here because the schema is not correct. So state tree AI. And exactly as we did in the state tree actor, we can start the logic automatically, or we can do that in blueprints, or we can add these components through blueprints or add multiple components to it. The rest is then all the same. Now that we have added the components with the state tree assets, let's go and have a look at the state trees themselves. When we open our two state trees, we see that they are superficially very similar. So this is the state tree AI using the state tree AI component, and this is the actor version. The difference comes in the actual schema. So we had to choose a schema when we created our state tree, and then we added that to a component that corresponded to that schema on an actor or an AI controller. The schema then gives you access to a context actor class. And this is the class that the state tree is expected to run on. So in the state tree actor, we just get a context actor class called actor. That then gives us a reference to the actual actor that it is running on. In the AI version, we are using the state tree AI component, so we get an AI controller class and a context actor class, because an AI controller will run on a pawn. We then get the actual references to the pawn and the AI controller, and these references are available to access throughout the state tree. These classes are by default set, but you can specifically set them. So we know that we're using AIC state tree. So in the AI controller, we could change that to AIC state tree. And then you notice that the reference that we now get will correspond to the AIC state tree. Same in the actor, we could change the actor to a BP state tree actor. And then this context changed from actor to BP state tree actor. So now we have a reference to that specific class instead of a generic one. And you can decide at the start of making your state trees whether you want them to be generic or specific. The more generic they are, the more reusable your state trees are for different actors. And it's worth making that decision early, because changing it later on can sometimes cause unexpected issues. You can change the actual state tree component schema here as well. But again, if you've already attached it to an actor or an AI controller, changing it might cause some issues. So that looks at the schema, which gives you access to the actual reference to that actor it is running on. Under that, you now have access to parameters. So you can go to the parameters, you can add a new property, you can choose its type, so it can be almost anything that's available. Put that as a float. You can rename these parameters. Test float. You can set a value here. You compile. And then when you go back to the actor that this state tree component is attached to, and you compile again, you will find that you now have access to this variable here. So you can click it on, you can change the value, and this value here will override the one in the actual state tree. The same is true whether you use the add state tree component. So again, you'll have access to that test value, and you can change that here, which will override the value in the state tree. And you could use this to set things like damage or what animations are to play, and so on. You should consider these parameters as being constants. There are ways of changing it in code in a state tree blueprint task using property reference nodes, which means that you can use this parameter list as a type of blackboard. There used to be issues in the previous versions with packaging, but I think that's been fixed from 5.5.4 onwards. Under that, you then have access to other options, each of which are needed to actually run the logic of the state tree, whether they are evaluators or global tasks. And we will look at these in future videos. Below that, you have access to a theme. So the theme allows you to change the colors on your state tree, and you can easily add a new one. So different theme, and change the color. This theme is then used in states. So when you go across to your central window, as I said at the beginning, a state tree always enters from the root. And from the root, it then has states in a tree-like fashion. So you can easily add a state by just clicking Add State here, or you can right-click and choose either a sibling state or a child state. The difference between the two is that a child state will be underneath, and a sibling state will be part of almost a different part of the tree. On any state itself, you can right-click and add a child state or a substate to that. And you can rename them here, or you can click on the state, go across to the details panel, and here you can change the name. You can give a state a tag if you've created one. You can change its color based on that theme that we've created. So I could change this to a different theme, and that might represent a more urgent task. By the same token, a state can be one of multiple types. So it can just be a state which runs tasks. It can be part of a grouped state. It can be a linked asset to another state or to another state tree, or it can be a subtree. And each of these can be part of the logic by which your tree functions. You can also add parameters to any state. And the difference between these parameters is that these are more global parameters. So they're available to access anywhere in the state tree. Whereas the parameters you add here, which again can be of any type, can only be accessed in the state or in its child states. And again, they can be set through blueprint tasks. You then have other more sort of complex options that allow you to control the logic by which these states can be entered or not. So conditions can be added. There can be a selection utility, which is a utility AI feature. And then under that, you have your actual tasks. And the tasks are what run the logic of any state. So whether this is an idle state or a chase player state, that logic would be contained within a task. And those tasks can be added just by pressing on the Add New Task button. There are some built-in tasks available. So running environment queries, showing debug text or delays, and you can create your own tasks. Underneath, you then have your transitions, which contain the rules by which a state can transition from one state to another state. And there are lots of different options available here. So you can have triggers on whether it's completed or whether it receives an event. You can choose which state it transitions to. So basically it can transition to almost any other state in this tree, as long as it meets the conditions of that transition. You can set priorities for the transition. So again, if two states are trying to transition at the same time, the one with a higher priority will succeed. You can add delays to that transition and conditions to that transition. So again, there's lots of built-in ways of controlling the logic that drives your state trees. In terms of the editor, there is also an outliner available. So this represents the state tree as an outline. There is also a state tree statistics window, which will give you stats on your global tasks and other statistics. There is also under window a debugger available. So this allows you to debug your state trees. Finally, if we go to this part of the editor, you have your usual save. There is a compile, and there is the option to save on compile, which is always worth setting. From here, you can create new tasks, conditions, or considerations. And when you click down, you have access to the built-in base class for state tree task, blueprint, condition, or consideration. So that's a basic look at how you can set up your state trees by enabling the plugins, by creating the components, by adding them to actors or AI controllers. And we've had a superficial look at how the editor is set up, looking at the schemas, parameters, themes, how to add states, and all the options that are available. In the next videos, we'll need to look at how to create actual tasks to run on these states, because the task is what drives the logic of your tree, combined with the transitions and other complex controlling behavior.